name is Derek Pridmore. I'm the CEO and co-founder of Aaro. We're a San Francisco-based machine learning company providing software that powers robotic automation solutions in the materials handling and manufacturing market. Our team is made up of talented software engineers, machine learning engineers, and roboticists, many of whom studied right here at MIT, but we also have deep industry experience, and we're using that experience to bring robots to new environments. The fundamental problem that we're tackling at Aaro is expensive and hard to find labor. Our customers are large companies in the materials handling and manufacturing sectors that face labor shortages, usually because these jobs are far from cities, they're tedious and highly repetitive. For instance, in e-commerce settings, it's not uncommon to find turnover rates that exceed 200% for piece-picking applications. These problems are particularly acute in markets like Japan, where the workforce now declines at a rate of 1% per year, which equates to 5,000 workers per day. When you combine these labor market dynamics with the growth of e-commerce, it's clear that this problem is going to get more acute. So the solution is that we have to automate these highly repetitive tasks. Aaro's solution is to apply machine learning to allow robots to enter new markets. Our vision and control software allows customers to automate applications like piece picking, depalletizing, food packaging, food inspection, product inspection, and more. Our product for e-commerce is called Aaro Pick. It's a software system designed to automate piece picking in warehouses, especially those that have high velocity inventories that are used in rack storage systems. Aaro Pick really has three major advantages, three core strengths. First, our vision system is the most robust, flexible, and low cost on the market. Second, we're hardware agnostic, so we're compatible with a wide variety of robots, including every major robot manufacturer, as well as a wide variety of end effectors. We can do everything from large arrays of suction cups to small, flexible end effectors, and that lets our customers choose the hardware that works best for their applications. Lastly, our software is designed to be tightly integrated with rack storage and conveyor belt systems so that our customers get larger efficiency gains and they get them at scale across the entire facility. We partner with some of the world's largest materials handling integrators so that our customers get the hardware maintenance and support that they need. Here are two examples, if it'll play. You can kill the music, of our software work. On the left, you see a food handling application. The robot there is made by a Japanese company called Denso, and the end effector is made by a company called Nita, and it's approved for food handling applications in Japan. On the left-hand side here, on the right-hand side, you see an e-commerce pack-out application that we did with Dematic at ProMat this year. And it shows not just our software reliably picking over many hours, but also our machine learning technology learned to place items so that they minimize the packaging space, which is important to our customers. The fact that both systems are running with the same set of software shows the flexibility of our framework. If your company produces or distributes products and you want to reduce operation costs or increase throughput, please drop me an email or catch me after the talk. We'd love to talk to you about setting up a demo. We can use our software to power your piece picking applications. Thank you.
Hi, my name is Ophir. I'm co-founder and CEO of Dust Identity. We're a supply chain security company that initially started working with the Department of Defense on securing supply chains for the most critical assets. And what we found out through this journey of really trying to solve the general problem of being able to trust objects. When you're holding a replacement part, whether it's a circuit board that goes into a data center or a replacement part that goes into an aircraft, at the end of the day, you need to be able to trust that object or to de-risk that object. And in a sense, what you actually need to do is be able to associate data with the object itself. And that linking between the digital and the physical domain seem to be the most vulnerable piece in supply chain security today. So being able to identify batteries, knowing that they're sourced correctly, making sure that the circuit boards that you're buying are actually sourced, the components that are showing up on those circuit boards are actually true and valid and won't cause any harm or a security risk. These are really concerns that we wanted to be able to solve. And that has to do with just being able to have that trusted physical binding between the digital and the physical. And what we see is that there's this general problem of being able to trust objects, whether it's parts or or products or packaging really spans the whole gamut of industries. Whether it's a value concern, where you're trying to sell a piece of art, knowing if the art is genuine or not is actually quite critical in that scenario, or being able to trust the type of food that you're purchasing. These are all places where you need to be able to associate data with the objects. For us, the most critical aspects is around security, maintaining the integrity of critical assets, whether it's defense platforms or, as I mentioned before, data centers, autonomous systems as well. And in order to do that, we wanted to be able to create that trusted physical anchor. So the solution is called DUST. DUST stands for Diamond Unclonable Security Tag, and it's the ability to anchor data to the physical objects using an unclonable marking. So what we do is that we put diamond dust, we engineer diamonds to have some unique quantum properties, and then we use that in order to create that fingerprint, unclonable fingerprint on the objects, and then be able to associate data with specific items. Or specific areas on an item. So for example, you can spray coat the entire circuit board and then define specific touch points that you want to be able to validate or you want it to be able to associate data with. Of course, on top of that identity, we can add additional processes such as writing into blockchains and other things whenever it's necessary, such that the asset owners can improve their trust in the supply chain. If you're interested in learning more about our solutions or you're having concerns about supply chain security in general, please come to the booth downstairs and see a live demo of our solution. Thank you very much.
Hi, my name is Lyle Odner, and I'm the co-founder and CTO of RightHand Robotics. This is going to be a little familiar if you saw Derek's presentation about 5 minutes ago. So the big problem that I think everybody is seeing right now, if you have any kind of a fulfillment or supply chain operation, is that the tendency toward moving to fulfilling things in individual units rather than cases is creating a demand for a whole lot of labor. And this is a problem in consumer goods, e-commerce obviously, but also in pharmaceutical distribution, in automotive. There just aren't that many people out there. What we make is a complete product. It comes in a crate, you unpack it, and you plug it into your system. It includes a set of 3D cameras for imaging the environment in your warehouse, a proprietary smart gripper. We believe that if you really want to tackle a wide variety of inventory, you are going to need some kind of custom hardware, and then a controller that includes a lot of interesting machine learning software. So here's it in operation, because this is really the important thing about having a robotics company, is you get to show a lot of videos. And let's talk about what we're doing here. So we're picking, scanning, and inducting with this system. It's just picking out of a bin of random consumer goods, and I want to really spend the rest of my time talking about why this is interesting and important. So your average grocery store has about 45,000 distinct stock keeping units. An e-commerce fulfillment center may have 10 times that many or 20 times that many distinct products. There is absolutely no way you're going to come up with a database of prior knowledge about each one in order to pick or handle it. And so that basically motivates you to apply some technique like machine learning, which is what we're doing, and very intelligent system design to handle this problem. As to what we're looking for in partners, we are in production. We've had robots continuously fulfilling orders for about a year. We are rolling out scaled deployments this year, and we are very interested in talking to anyone who has scaled applications for automated model-free piece-picking systems. So I'll be downstairs and looking forward to meeting you. Thanks.
We go to the first slide, please. Okay, my name is Matt Reynolds. I'm a 3-time MIT alum, PhD from the Media Lab in 2003, and founder and CEO of Throughwave. We're based in Seattle, Washington. Our mission is to make the invisible visible with human-safe millimeter waves. And I mean two things when I say make the invisible visible. First, our human-safe millimeter wave imaging system makes 3D images of the interior contents of packaged goods. For example, we can take a 3D image of the item-level contents of a case without opening the case. We image through packaging. The second way I mean make the invisible visible is that we take those images and we automatically interpret them to understand supply chain process variables like item count and so forth. So here's an example of what our sensor can do. You see on the left-hand side a sealed box. We are showing you a cutaway in the middle just so you know what contents are there. The image on the right is what our sensor produces. This is one depth slice out of a 3D image data set that's like a CT scan or an MRI. It's made in layers. And we can take those layers and make a 3D view, for example, a 3D point cloud of the objects that are inside that box, again, without opening the box. So we're working on supply chain manufacturing and logistics problems. In particular, we're looking at automated auditing, so counting items inside the packaging, detecting missing or damaged items, verifying incoming inventory in manufacturing, and we can also do exterior dimensioning, all with the same millimeter wave sensor. And here's an example. This is from a company that's in the apparel business. They source t-shirts from overseas. The t-shirt on the left is okay. The t-shirt on the right has broken needles that were introduced during manufacturing. That's a quality problem that has to be stopped before that goes to the customer. Again, we can do that without opening the package, and we can do that on a stack of t-shirts. Our technology stack includes the sensor as well as analytics and ML that interpret those images. We can do this at speed, so we can do this on a 600 foot per minute conveyor, so very fast. That feeds a warehouse management system or a manufacturing execution system, which then feeds data into your ERP system. So we would like to meet companies that are engaged in manufacturing, particularly high-value manufacturing with a lot of component parts, companies that do fulfillment in e-commerce or in direct-to-consumer, and companies that do logistics and supply chain operations where there's a lot of material handling. Thank you.
Oh, Incbit. Sorry.
Good morning. My name is Davide. I'm the CEO at Incbit. We are an MIT spin-out from the Department of Computer Science and Artificial Intelligence at MIT, from the lab of Wojtek Matusik. Wojtek is one of the pioneers, one of the leaders in the emerging field of computational fabrication. He's bringing the power of machine vision and machine learning to manufacturing. So we all know that 3D printing has the power to transform manufacturing. Yet many challenges remain, and especially today, there is no single platform that has the speed, the precision, and the multi-material capabilities to be ready for a factory floor. At Incbit, we have built the first 3D printer with eyes and brains. Our machine learns from its mistakes by scanning every layer at micron resolution immediately after deposition. If there are discrepancies from the expected geometry, they are immediately corrected by remapping the next layer. So these data are also used by a machine learning algorithm to enable the machine to learn the properties of each material and anticipate their behavior. For example, if a material has a tendency to shrink, next time the printer will print a slightly larger geometry to compensate for this in advance. So with machine vision and AI at its core, our printer can print multi-material parts with precision, speed, and reliability. It also creates a digital record, a digital twin of every single part it prints. The machine was developed in partnership with Johnson & Johnson, who will use it for manufacturing a personalized medical device of intricate geometry. Because of machine vision and machine learning that we have integrated into our printer, our machine is designed for the factory floor. It prints with speed, precision, and production-grade materials. We expect that our platform will enable engineers, product designers to go from an idea in their mind to a functional prototype all the way to a volume production, to a product that can sit on shelves very rapidly and without changing platform. We're looking to partner with leading companies in fields such as healthcare and beauty and automotive aerospace, where precision and production-grade materials are important. So please come by my desk later, and I will tell you more. Thank you.
My name is Ali Merchant, and I'm the CEO and co-founder of IQ3. We are building the next generation virtual reality software platform that enables engineers to collaborate in 3D from anywhere in the world. Think of us as WebEx in 3D for engineers. Finding a design error in this after the fact can be very expensive. Once this is manufactured, to go back and fix an engineering problem can cost millions of dollars. Imagine if a design engineer could, in one part of the world, could collaborate, stand right next to a service technician in a different part of the world, and the service technician could just point and say, I can't access this part. Such design problems could be resolved almost effortlessly. And redesign costs could be saved and time to market. Today, virtual reality could be used to solve these problems, but it's extremely expensive. It is hard to use and very hard to scale up for mass adoption in an enterprise. We have solved this problem. With IQ3, anyone can collaborate in 3D from anywhere in the world. Sorry, there's a video there, but thank you. So with IQ3, all you need is a browser, and it's as easy as starting a meeting. You can instantly throw in complex 3D manufacturing data and invite anybody to just collaborate with as simple as WebEx, as a WebEx link. And just like a WebEx, you're in a fully interactive 3D environment where you can actually go in and resolve and redesign your problem in real 3D from anywhere in the world. And from any device. Our customer, AVL, it's a $2 billion company that makes powertrains and test facilities for automotive companies. They used IQ3 as a 3D communication platform all the way from sales to project execution, involving customer and supplier collaboration. They estimate that they save about $500,000 per project on travel and engineering costs. Today, we have a released product that is being used for these applications. We are looking for companies who are interested in exploring 3D collaboration, and partnering with us on pilots and exploring how we can bring business value to the organization. Please come and test drive IQ3 today. We have a demo table. Thank you.